All right, so today we are solving rational equations. I mentioned before our fire drill that we have two options. Option number one is to combine this side into one fraction. So just subtract those two so you have one fraction, and then you can cross multiply. That's usually not your best bet though. Usually your best bet is to get all three denominators exactly the same. In this case, that won't be so bad. These two are already the same, 4x and 4x. What would I have to do with this one to make it be 4x? Multiply by 2x, right? So I'm going to take this very first fraction, and I'm going to multiply it by 2x over 2x. And let me just use this paper here. So now look at what I've got. I've got 6x over 4x minus 1 over 4x equals x plus 5 over 4x. Now that everybody has the same denominator, what I can essentially do is ignore the denominators, and I'm just going to solve the equation formed by the numerators. So I'm really just going to do 6x minus 1 equals x plus 5. And we'll solve and see what we get out. So I'm going to solve this like I always do. Whoop. So I'll add 1 to both sides, and I'll minus x from both sides. So I've got 5x equals 6. Divide both sides by 5. Thanks. So in this case, I got 6/5. That's your answer. That is my answer for x. And as long as it's not 0, it should be fine. I can check it, make sure it's not extraneous. So if I pop this back in, it's not going to be very pretty, but I can do it. So if I go back to the original said 3 over 2 minus 1 over 4 times 6/5. I want to see if that's equal to 6/5 plus 5 over 4 times 6/5. Yeah. Great question. Go back to an easy one like this. If I said like, I don't know, say I did like 3/5 plus 1/5. Isn't that 4/5? Right? Okay, so imagine that this was an x. Do I really care that they're all fifths? Wouldn't I just solve it the same way? Yeah, because when you are adding the fractions together, you don't change the denominator. It doesn't really matter. What just matters is that numerator. So as long as everybody's denominator is the same, you can ignore it, solve it, and just make sure that your answer wouldn't cause you to get a 0 in the denominator back in the original. But it doesn't, so we're fine. So yeah, you can check this. Do you want to? Look how nasty that is. Yeah, it's not nice. You absolutely should be able to, though, and it will check out. Okay, so let's try another one. If we jump down to one like number, look at 7. So 7's got 1 over n minus 3 plus 2 equals 8 over n minus 3. Well, exactly. Right now, that's a 2, but your denominator is really just a 1. So it would be very easy to get him to match these other denominators by just multiplying by n minus 3 over n minus 3. Just be careful. Always make sure that you distribute that. So now that everybody has a denominator of n minus 3, I'm just going to do this. 1 plus 2n minus 6 equals 8. That's it. Now I just solve it. Right? Oh, what was my, what value would give me a 0 in the denominator? 3. So if I do my workout and 3 happens to be my answer, I can't use it because it creates a 0 in the denominator back in the original. So let's hope that we don't get a 3. Yeah.
If that happens, you just say there's no solution.
Correct. All right, so I got a negative 5. Now I'll add the 5, 2n. Thanks. 13 divided by 2 divided by 2. So I got 13 halves.
Faculty and students, please.
Wait, why would you not get the denominator?
0.
First of all, mandatory meetings for approved step-up day.
For this one, I can't get 3.
Today,
Right,
tomorrow,
right.
Wednesday at 1:45 p.m. in the guidance office. Faculty have been emailed the list of approved students and are asked to release students tomorrow at that time. Students is planning with any questions. At this time, we would like all current juniors, grade 11, to report to the auditorium.
Guys, check with someone else what I end up assigning from homework. It'll be from this sheet. I just don't know what we'll do.
You will be dismissed directly to the buses from the auditorium this afternoon. Thank you.
Okay, so let's try one that's a little bit tougher, shall we? How about, ooh, it looks bad. How about 8? 8's not that bad? You don't want to do 8? I said 8. 16's kind of bad. If you look at 16. So think for a minute. What am I not allowed to get in my denominator? What would make me have zeros in the denominator down here? 0. I can't get a 0. So if 0 happens to be my answer, I have to throw it away. What? 16. Sorry. There's another number that I'm not allowed to get. No, 1 would be all right.
How are you getting that?
What would you plug in for x to get a 0 down there?
Oh, yeah.
So in that case, it's a 0. But you also have to think about it for this one. If I plugged in 0, that one would turn into a 0 also. But there's another number. 6, right? If you take this thing and you set it equal to 0 and you solve it, 6 would make that denominator turn into a 0, right? 36 minus 36. So if when I do the math, right, and I get a final answer, if my final answer is a 0 or a 6, I have to throw them away because that creates a 0 in my denominator. So in other words, 0 and 6 are my excluded values. All right, so let's do it out and see what we actually get. So 16, you've got 7x minus 49 over x squared minus 6x plus 1, I'll just write it as 1 over 1, equals 7 over x. Okay, what I recommend to you is to factor the denominator if it can be. So this one can be. Let's take out an x. You're left with x minus 6. So remember, I'm trying to get common denominators. So I'm going to have to multiply this guy by x minus 6, right? And then this one needs both of them. Do you see that? Are you with me? So I'm going to multiply this guy by both of them, x and x minus 6. And this one just needed the x minus 6. Does everybody now agree that everybody has the same denominator? You agree with me? Yeah? Okay. So here's what I got to do now. Now I'm just going to solve the numerator. So 7x minus 49. Now, if I multiply all this together, that's going to get me x squared minus 6x. And don't forget on this side, now I have to distribute. So that's a 7x minus 42. So far, are we okay? All right, now I just have to solve this equation. Looks like it's a quadratic. That x squared is not going to go away, so I may have to factor or do something here. But I know I want the whole thing to equal 0, so let's minus 7x. And I'll add the 42. And I'm going to write it in standard form to make my life easier, so I'll put the x squared first, minus 6x, and then negative 49 plus 42 is a minus 7. Is this all right so far? Yeah? Okay. Now, I got to solve this, so what am I going to do? Yeah. Are there factors of negative 7 that add to be negative 6?
Sure.
Negative 7 and a positive 1. So that means my answers are really positive 7 and a negative 1. Were either of those excluded values? No, they weren't. They were fine. Remember, it was 0 and 6 I couldn't have. But I didn't get a 0 or a 6, so I really don't have to worry about that. Does it happen? Yeah, it does. So you really have to be careful. All right? Don't forget to go back and check those. Do you want to, these are nice numbers. Should we just check them real quick since we didn't check the other ones? Yes, because I want you to believe me that this really does work. So here's my original. So if I were going to plug in 1 very quickly, 7 minus 49, that's a negative 42. Oops. And if I put 1 down here, 1 minus 6 is a negative 5. Plus 1, so why not write it as 5 over 5? Does that equal 7 over 1? Well, let's see. Negative over negative is a positive. Add those two together. That's, this does not work. Hold on a minute. Did I mess up? 1 minus 6, negative 5. So that turns positive. Make that 1 over 1. Oh, it's a negative 1. Duh. Duh. Dopey. Okay. Plug in a negative 1. That should work. So that would be negative 7 minus 49 is a negative 56 over 1 plus 6 is 7 plus 1. Does that equal 7 over negative 1? Well, what's negative 56 over 7? Negative 8. Is negative 8 plus 1 negative 7? Yes. All right. Negative 1 really does work. 7 really will work too. Watch. 7 times 7 is 49 minus 49 is 0 over, let's see, 49 squared minus, who cares, but it's not 0, so something, plus 1. Does that equal 7 over 7? 0 over anything is 0, so I don't really care about that. As long as it's not 0, it's not. Is 1 equal to 1? Yay! So you really can check these, especially when your answers come out nice. It's not so bad. So when you are taking your next test or quiz, give it a shot. Let's see. I'm trying to think of a good example of when you might want to... say I gave you a problem like this. I'm just going to make it up, so I have no idea if the numbers will come out nice. Say you had that. Here, it wouldn't be that nice to get all of the denominators the same. Could you? Absolutely. But it's not so bad to get these two the same. Right? Can't I just combine those two? That's not so bad. What would I have to multiply the 1/5 by? X over x. And I'd have to multiply the 2 over x by 5. All right, so that would get me here. 4 over x plus 2 equals, that would be x minus 10 over 5x. You with me? Now, my denominators aren't the same across the whole board, so I can't ignore them. But what you could do now is now you could cross multiply. Anytime you have a fraction equal to a fraction, you can just do those diagonals and solve from there. So that'll actually make your life a little bit easier. So again, I have no idea if this comes out nice because I just made these numbers up, but if you're going to do it, let's try it. 4 times 5x is going to be 20x. Now, when you multiply x plus 2 times x minus 10, what do you have to do? FOIL! Oh my gosh, FOIL! X squared minus 10 plus 2 is a minus 8x minus 20. And now we would just solve this like usual. It's a quadratic, so we'll minus that 20x from both sides. I do not think that this one is factorable. Can you think of factors of negative 20 that add up to be negative 28? I don't think so. But we're Tantasquins, and we have all these tools in our toolbox to solve this. So if you can't factor it, what are you going to do? You could use the quadratic formula. What else could you do? You could complete the square. Would this be a bad one to do complete the square on? Yeah, as long as b is even and a is 1, completing the square is not that bad. And since our final is, what, 2 weeks from today? Why don't we recap completing the square, huh? Do you remember what step 1 was? Move C to the other side, right? First of all, I like the equal 0 over on the left, or on the right, sorry. It really doesn't matter, but I like it over there. So I'm going to move C to the other side, x squared minus 28, and then I'll add 20 over here. Then what do?
Do you take half of
You got to do something before that. Half of B and...
Divide by 2, right?
No! Square it. Take half of B and square it. So half of B, oops, forgot my x. Half of B is 14, and 14 squared is 196 to both sides. Remember this? Now, on the right, you just add those two together. So, what's that? 216. And then on the left, that's factorable, but it's always the same two factors. So instead of writing it twice, I just write it 1 time squared. Do you remember what's in there, though? I'll give you a hint. There's an x. What goes here? Oh, has it been this long?
X plus 14.
Minus 14. Same sign that you had. It's always half that number. Minus 14. Now, do you remember what to do? Square root both sides. Square root of u, square root of u. I just get x minus 14. And now we're going to leave this in simplest radical form. I got to find a perfect square that divides into 216. There's my list. I want the biggest one that divides into 216 if we can find it. I think I might have it. 36 goes in 6 times. So what does this turn into? Someone's saying it. 6 root 6. But, what did we forget? Not yet. Plus minus. Anytime you take a square root, you need plus minus, and then we'll add the 14 to the other side. You get 14 plus minus 6 root 6. There's the final answer for my crazy made-up problem. Yay! All right, so, guys, that's kind of the gist. As you're looking at these, the ones on this sheet, your best bet, I'm looking at these quickly, and I think that you're going to be best off just getting all the denominators the same. I don't see many where it's going to save you time to just combine the two and cross multiply. Oh, you know what? I take that back. Number 9. Look at number 9. These two already have common denominators, right? So you can just add those two together right now and then cross multiply to get your answer. Instead of multiplying this side by 6x. Is one a huge time saver over the other? Not really, but that would be an option here because it's already set up. And then you can just boop, boop, and solve, and you're done. All right. How do we feel about this? Okay? You want to try some? All right, let's stop this video and hope it recorded.